So now we're looking at these composite parts, and it's giving us a lot of information. So the centroid of this hemisphere, it would be at x equals 60 millimeters here. Yeah, there's the 60. And y would be negative 2 times the radius over pi. Look it up in the back of the book. This centroid's at 20 millimeters. This centroid's at 10 millimeters. They're all equal mass wires. So we can take the length. Now, it does help to set things up like in an Excel spreadsheet, and the book is going to show you that. So length 1. So length 1 is pi times 60. It's just the length of this arc. Length 2 is 40, and length 3 is, so there's number 1, number 2 segment, number 3 segment. Center of mass, x coordinate, y coordinate, let's see. There, yeah. It's negative because it's in the negative y direction. X coordinate, now for the two wires, let's take a look at the x coordinate. Yeah, they'd both be 0. You'd have a z coordinate, you'd have a 10 millimeter z for this final one, by the way. Okay, and here we have it. 10 millimeter z, 20. This 20 is in the middle, number 2. Number 3, it's at 40 millimeters. Okay, oops, wrong direction. There we go. So all the locations of the centroid, total length. So we add up x times L, and we get this. Well, that's why a spreadsheet works out very nicely. You can just use a formula. You can take this cell times this cell equals this cell, and just copy and paste it down. And if you use absolute references, you can just, for L, you can use an absolute reference. So you can just copy all 9 and then get the sum of each row, the sum of L, and just plug and chug from then on. Set up your spreadsheet, plug and chug. I want you to notice something. We're not, our formula said mass, but you guys can figure out if there's a constant density per unit length, then mass is that density times length, and it'll cancel out in both sides of the, it'll factor out. If density is different, you'll need a density column. Say one material, one of the pieces of the composite is brass and the other is steel. You'll have 2 different densities. So you have to do, for this, you'll have to do x bar rho L for whatever rho it is, whatever density it is. And here you'd have the total weight, density times L, or total mass. Okay, thinking through this stuff. So this is another composite. So let's think about this. This will be, so area number 1. This is actually a bit easier than the other one. 2, area number 3. X3 is equal to 1 foot. Y3 equals 1. X2 equals negative 1 foot. That's just 3 feet. So Y2 would be 1.5 feet. and x3. Centroid is 2.5 feet in the x direction negative. And y3 is half foot positive. Okay, mass or area equals 1/2 base times the height. Base times height is 9. I'll leave the units in this time. Just saving time by not listing the units. All these coordinates are in feet. The area of 2, so this is A1, A2 is going to equal 2 times 3, 6 feet squared. A3 is going to equal 1 foot squared. Okay, it's going down. It's basically telling us everything that that I just went through. Setting it up, let's see. Area, 4.5, 9, -2. Area, 4.5. Well, where did I get the 9 from? 3 times 3 is 9. Oh, they're doing a subtraction. Take a look. So I would have done it differently. I would have added up all these 3 areas. I was going with that. What they're doing is they're taking a 3 by 3 plate and they're subtracting off a 2 by 1 plate. Okay, so I'm going to draw in the dotted lines. So this illustrates subtraction. I'm glad they're doing it. I forgot about that. So the centroid here, the area would be area 4, I'll call it, equals 2 feet squared. The x4 is going to equal -2.5. And the y4 is going to be 2. So we got to subtract off that mass. So let's go look at it. 4.5, 9, -2. And of course, the big A5, A4, 9 is A4 plus A3 plus A2. Does that make sense? 6, 1, and 2. Yeah, it's the sum of the 3. Oops, wrong direction. There we go. So that's where the 9 comes in. Big 3 by 3 plate. Subtract off the 2 by 1 plate. Okay. The 3 by 3 plate, -1.5 in the x direction, +1.5 in the y direction. XA, negative, okay, there we go, YA. They're moments, so you got to keep track of your positive and negative signs. That's the the 4.5 foot. Yeah, that's the triangle. 1, 1. Anyway, crunch the math. -2.5, 2. Is that what we came up with? -2.5 and 2. The 5 is kind of hard to read, but it is 2.5. Okay. So that's the area. Negative sign here just to indicate we're subtracting it. So by putting the negative sign here, it reverses. 2 times -2.5 would be -5. We're adding 5. 2 times -2 would be a +2 would be a +4. We're subtracting. Add up all the XAs, take the sum divided by the total area, and we get this. Okay. So, this one's another composite, except it's dealing with solids, and this is a good time. We've been talking about examples quite a bit. In fact, this video is about twice as long as it should be. I might just cut it in half. So don't be surprised if that happens.